Most engineering relies on work extraction through blunt interception. We assume that to generate power, one mass must strike another in a physical collision. The dual caustic universe framework defines this model as Taghūt, or B-force, a system where work is dependent on the friction of impact. In 1913, Nikola Tesla patented a turbine that moved away from this interception model. He removed the blades entirely. Instead of catching a fluid with a physical barrier, Tesla's design uses the boundary layer effect. It relies on the fluid's natural tendency to adhere to a smooth surface as it passes. This shift demonstrates a specific structural principle. True power, or Rūḥ-mode operation, emerges from invisible viscous coupling rather than the resistance of mass. In this system, high-velocity fluid enters tangentially between smooth, parallel disks. Instead of bouncing off a surface, the fluid spirals inward towards the center. As the fluid moves, its internal friction causes it to stick to the microscopic boundary layer of the metal. This viscous drag is what pulls the disks into rotation. Because there is no impact, there is no shock. Work is extracted through a sustained rotational authority that bypasses the chaotic energy loss of a bladed design. This creates laminar dominance, a state where changes in direction and velocity are gradual, following the fluid's natural streamlines of least resistance. The mechanics here suggest a broader rule. Controlling the interface of a flue field is more effective than attempting to dominate its mass. To understand this as a universal engine, we must map the turbine's physical components to the three operators of the dual caustic universe. The smooth disk stack represents the buffer, or B operator, providing the physical interface where energy is transitioned from a field into a form. The fluid itself is the sound caustic, the S field, the thermodynamic medium that carries the potential for work. The nozzle is the light caustic, the L operator. It acts as the geometric constraint, dictating the precise rule for how the input must enter the system. The microscopic gap between these disks represents tau, the decoherence time. If this gap is too wide, the fluid loses its grip and slips. If it is too narrow, the fluid locks against the metal. The spacing must match the boundary layer exactly. Work is produced only when this B interface is calibrated to the flow. The turbine demonstrates motion emerging from a perfectly tuned interface. Even when this interface is perfectly tuned, engineering tests show that the Tesla turbine reaches a specific efficiency limit. This practical efficiency peaks at approximately 30%. While it seems low, this number represents a hard structural constant found across entirely different domains. In C4 photosynthesis, the conversion of light into chemical bonds follows this same 30% efficiency ratio. In physiology, the cardiac ejection fraction, how much blood the heart pumps with each beat, shares this 30% threshold as a baseline for coherent function. This ratio represents the optimal transfer of energy from the S field before a localized system loses coherence and decays. Across creation, this 30% constant serves as the maximum load a localized form can bear before the illusion of control is lost to entropy. When we attempt to force a system past this 30% equilibrium, the physical architecture begins to fail. At high velocities, the fluid separates from the disk surface, laminar dominance ends, and the flow erupts into chaotic microvortices, destroying the system from within. In the DCU, this point of boundary layer breakdown is identified as the Shayṭān state, where the interface can no longer mediate the field. This state is described by the mathematical expression a+b+c equals 0. Here, the individual parts of the system exert energy, but they cancel each other out. There is no shared direction, no qibla, and therefore no work is performed. When a system hoards potential beyond its calibrated limit, that energy is no longer useful. It converts directly into localized destruction. This transition from smooth order to chaotic turbulence is the physical key to understanding prophetic authority. The Quran describes Solomon, Sulaymān, as having a unique command over the wind. Verses 21:81 and 34:12 show this was not a power of brute force. Solomon's authority was laminar command. He directed the wind by governing its pressure gradients and streamlines, rather than fighting its mass. His governance follows the logic of the turbine. He exercised command over the S boundary, allowing the field to move the kingdom without the need for B-force impact. The Rūḥ of Allāh does not push reality. It aligns reality from the boundary layer, manifesting authority through the precision of the interface. We see this same boundary layer logic in the physics of our atmosphere. Wind is merely an S field advecting moisture toward a boundary. It carries no inherent destruction. The outcome depends entirely on the state of the interface. When moisture accumulates within the laminar limits of the boundary, the field releases that energy as rain. But if the density crosses the threshold into turbulence, the flow collapses into the high-energy stabilized state of hail. The hailstorm is a Razim purification, the same mechanism that separates order from chaos by forcing a state change when a boundary is overwhelmed. Authority is the ability to maintain the S boundary. B-force, or destruction, only emerges when a system crosses a threshold and must discharge an imbalance. Maximal power requires minimal impedance. Whoever governs the invisible boundary layer governs every outcome in the field.